For this experiment, we're gonna be using copper, brass, and cast iron. We're gonna weigh them on a scale, 45 grams, right on the money. And what we're gonna do is we're gonna put them in the water. The water's gonna be at 100 degrees C. We're gonna wait for the piece of, or our sample to reach an equilibrium temperature of 100 degrees C. And we're gonna put it in this cup here, this Yeti, which is nice and insulated, and has water in it, about 230 grams worth. And we're going to see how much water, how much heat the water absorbs. And then we're gonna use that to calculate the specific heat capacity of our materials. So over here we have my thermometer hooked up to an Arduino to magically record temperatures. Precisely, I might add. And I also have an Excel sheet built up. And what I have here is basically our first example. The initial temperature, basically room temperature, at 23.75 degrees C. The specific heat of water, the mass of the water, the mass of the object, and then material brass. And basically what we're gonna do is we're gonna wait till, once the brass comes out at 100 degrees C, drop it in the water and wait for that temperature to equalize, and then use that new temperature to calculate our specific heat of the brass. So, safety first. Let's get cooking. So what we're gonna do on this episode of America's Top Chef is basically wait for this brass here to get to 100 degrees C. So let's wait. Well, the key to cooking good brass is to, well, look at it. Okay, let's move it out. Oh, that's nice. Now they got a good char on them. You know, I didn't want the temperature too hot. You gotta get this brass just right in a nice medium rare. Okay, so what we're gonna do now is we're gonna come over here to our Arduino code and our temperature sensor and wait for this bad boy to read the highest temperature from the brass. Failure. Okay, so after the experiment, we recorded our data, and we find that the equilibrium temperature for the brass was 26.99 degrees Celsius. The sample was heated to boiling, 100 degrees Celsius. And we used our little equation here to calculate joules, the heat transfer to the water. And then we set that the heat transfer of the water is equal to the heat transfer of the sample in order to calculate our new CP, or our sample CP, and we get 0.3825 or 27. And then we can go and compare that to the internet's version, and we see that brass is 0.38. So we're pretty close. Not bad, people. Some might say it's almost perfect.